Hi guys, Sam Marsden here from the Wolfhound channel. So this is our continuation of the book, How to Think Like a Computer Scientist. So we're on chapter 2, and that is variables, expressions, and statements. And we're going to jump right in here. We're going to jump into part 2.1, and we're going to talk about values and data types. So we're going to use the built-in function here called type. Now, this is something that is in the back end of Python. It's a function that is used to evaluate either variables or data that you're looking at. So we can either put a variable like say x in here, or we can put a value of say 5. And we put it in the enclosed brackets, and it returns, and it tells us that that thing we're looking at is an integer. And trust me, as an experienced computer scientist, this is a lot more useful than you think. And we can just run through a few different types here. For instance, if I put 5.1, we're going to see that it creates a float. Now, floats are unique because they have decimal places, as opposed to integers that have none. And you might be curious as to how far out those decimal places can go. Well, in fact, it's an exceedingly large amount, because what happens is Python will store the value as a binary fraction, and then it will approximate the overall value that you're trying to basically get to. And it is very accurate, because for instance, you can take something and you can divide it by 2 to the power of 55, which is an exceedingly large number, and Python will be able to handle that. Now, moving on, because I don't think you need to do that sort of level of division just yet, we'll talk about data types such as strings. So you can put in your name, spell that right, need to close it off, and this is going to give us a string. Now you can store almost anything as a string. You can convert anything into a string, but you can only convert certain things from strings back into their original values. So you can convert, for instance, the string 5.1 back into a float, but you can't convert something like my name back into a float, back into an integer, or into a boolean, which we're just about to see. For instance, there is one other data type that we have, and that is a boolean. And booleans can only ever be true or false, either a 1 or a 0. And that's really critical, because that can be used for various logical purposes, but also to toggle things on and off. So moving on from there, another important thing to mention just about strings actually is that if you have different quotation marks within them, so you can encapsulate a string within either single or double quotation marks. If you have double quote marks, you can put in single quotation marks in between. If you have single quotation marks, you can put in double quotation marks in between. Now, if you want to have single and double quotation marks in between either single or double quotation marks in the end, what you can do is you can use triple quotation marks, type what you want, put in the different quote marks that you want, and then close it off with triple quotation marks. And that allows you to do it, and that will store it inside that value. And in terms of storing values, which brings us on to the next part, is we're going to talk about saving things into variable names. So for instance, x equals 5. And now an important thing with this is, if we check the type of this, it will say to us that x is an integer. Now, if we save a new value into x, for instance, a float, and then we evaluate what x is, it will tell us it is a float. This is very different from other programming languages, because in other programming languages, once you set x equals an integer, you can only bring integers into x. And if you tried to save a float into x, it would say, no, this is the wrong data type. This is the wrong data type for this variable. So that's important to bear in mind. It's also important to bear in mind sort of manipulation of how things can be added together. For instance, we know x is a float, And what will happen is if we have y equals an integer and then we add x plus y, we'll find that we get a float out the other end, because that's the behavior that Python has, that it takes. If you take an integer and you take a float, you add them together, you get a float out the other end. So that's something else to bear in mind as you're writing your computer programs. Whenever it comes to variable names, we generally stay away from capital letters, but you can do this, and that is you can do camel casing. And camel casing is where at the start of each of the words that you're wanting to put in your variable name, you use a capital letter. And this is in line with the PEP 8 style guide for Python. Yet again, I'll have a link in the description for that. Another thing about variable names is there are some that you can't use. This is taken directly from the book, How to Think Like a Computer Scientist, and it talks about and, as, true, false, none, class, if. All these names are built into Python as the fundamental operations that it carries out. Therefore, you cannot use them. So, we're going to talk about statements now, which are instructions that Python understands and knows how to execute. And then we have essentially evaluating expressions, which are made up of a combination of values, variables, and statements. And basically that forms logic that Python understands and can execute. For instance, if we have 1 plus 1 equals 2, or if we ask for the len of a string, and I just type some rubbish here, we'll get that that is 7. We also have operators and operands. Now, operators are sort of special statements that are sort of core to Python. For instance, like plus, like minus. We have multiplication, for instance. We also have division. Now, we have two different types of division. So we have normal division, which will get us a float, and we also have floor division, which will always move the number further to the left on the number line. And if you want to see an interesting example of this, we can divide 6 by 4, and we're going to get minus 2, because it will move it further to the left on the number line. So that's important to understand. So let's quickly talk about type converter functions. This is whenever you have one type, for instance an integer or a float, and you want to convert it to something else, like a string. And that's dead simple. You just take the value of the thing you want. So for instance, if we have x equals 5, click here, x equals 5, and we want to convert it to a string, for instance, we can do that by just putting str, opening brackets, putting in our value, and seeing it returns there as a string. Now, x itself will still be an integer, as we can see there, because we haven't saved it as that. So if we want to, we'll put x equals our string, open our brackets, put it in. This is going to convert x to a string and then save it in the variable name of x. And we can check that now, which we can do, and we can also check the type itself. It is indeed a string. That's important to remember. Another thing that's important to remember is the order of operations. And this is the same as mathematics, where we do our parentheses first, we then evaluate our exponents, we then evaluate our multiplication and division together, and we then evaluate our addition and subtraction. An important thing there to note, not just in mathematics, but in Python, multiplication and division are done simultaneously. It does not matter in terms of the order, because when you work through the logic, it will work out. And the same thing there to do with addition and subtraction. They can be interchangeably done, but we do them in a certain way for essentially convention. Something else to move on to is essentially string concatenation. So if I have a string, right, which is my first name, and I want to add my second name to it, I can just do plus, and that will concatenate the two together, as you can see here. And that's very important to know, because subtraction doesn't work, and also multiplication does work as well, and we can multiply something 3 times and it will repeat, and that's also something very powerful that can be done with strings. Like I said, division and minusing away, subtraction don't work on strings in the same way, but multiplication and addition do, and they're very powerful tools, so just bear that in mind. Let's talk about inputs. In my engineering experience, they're not something you're going to use too many of or at all. Normally, when it comes to me writing my own programs, I write a configuration file, I get all the sort of core values I want from that file, and then I execute that within my program. The other way to do this dynamically is to have a GUI, a graphical user interface, and that's what you'll be most commonly familiar with. If, for instance, if you open up any program on your computer or PC, Mac, whatever, and they are quite useful, but they are something that can cause problems in your program. And to give you an example, we'll move on to the next section, which is going to be composition. So we're going to build a little program here. So if we want to know the area of a triangle, right, we know it's half a base times the height, but we want to get that from the user. So we're going to ask the user essentially to put that value in. Now, what we have to do here is we have to put input, and then we have to put a bit of text, essentially of asking the user what is the base of the triangle that we're trying to get, essentially. And we need to put a space in here. Now, that's important because that will prevent the value from being bunched up with the text that's going to be presented to the user. And what I'll do is I'll show you another way you can do it in this one here. So I'm going to ask, so essentially, what is the height? Now, what I'm going to do is, on the end of this, I'm going to put in a \n, which is a special character, which whenever it's in a string, will return it to a new line. Now, the input for both these values will be stored in base and height, but it will be stored as a string. So we need to know how to handle for that. And we need to convert for that, because we can't do the mathematics that we want on it. So we want to convert it. So what we're going to do is we're going to put in my spelling's atrocious, the float conversion function. And that is going to let us essentially change them into floats. If I just make sure for everything is correct. Yep. So now we have the inputs. We've converted them from strings into floats, and we can now perform the multiplication of essentially a half the base times the height, as you see here. But whenever we run this program, nothing's going to be spat out. So we have to then tell the program to print the answer. So we want to do that. And this is just me doing a wee bit of formatting the way I would do it normally. And whenever we put a comma, that is used to denote another value starting. So we can put another value in there. So we've got this basic program, and if we run it, you'll see it run on the right here. So it's going to ask us what is the base. So I'm just going to put in 5.62. It's fine. And you can see here, before we had a space in the line above, now it has returned it to the line beneath. And it has done that because we have that special character in there, which is that \n. So now I'm just going to put in 11.4. We've had a bit of an issue. And that is because I spelt base with a small b instead of a capital B. So if I rerun this program, and if we just put in 5, and then we just put in 4.6, we get the area is 11.5. Small spelling mistake, but it matters. So we have one final topic to discuss, and that is modulo mathematics. So if I have 7 and I divide it by 3, because I use the percentage sign, I will get the remainder, which is 1. This might not seem very impressive, but it is crucial. It is crucial to modern day passwords and cryptography. It was pioneered and developed as a cryptography technique by this man here, Alan Turing. He broke the Enigma code during World War II and is the modern, essentially the father of modern day cryptography and code breaking. I was actually very lucky to live beside Bletchley Park for a year, and I highly recommend, if you're interested, to go there and check out the museum. It's just amazing. But that's where I'm going to wrap this up for today, guys. Like and subscribe, hit the bell to stay notified, and until then, I'll see you next time.